Okay, fine. Now the Couette flow. If you go to the Couette flow, if you go back, so this is the Couette flow. Couette. Okay, Couette flow. What is the difference? Couette flow means this bottom plate is fixed and the top plate keep on moving with a velocity v. So that is the difference. So what are the conditions given? Again, same assumptions for the Poisson flow. What is the difference? I will tell. Steady laminar incompressible viscous flow between parallel plates, distance of h. Here one difference is that we are considering h varying from here bottom at y is equal to 0 at y is equal to h. Okay. Now flow driven by the upper plate moving at velocity v. So this is a major difference in the Couette flow. Flow is happening because of the movement of the upper plate. Because of this plate movement only, the flow is happening. That is the driving force. So there is no pressure gradient in the x direction. Dou p by dou x equal to 0. Okay. In Poisson flow, dou p by dou x exists, but in Couette flow, dou p by dou x is 0. That is the major difference. Okay, in the between difference between the Couette flow and Poisson flow. Other assumptions all are similar. Very wide, long. So there is v equal to w equal to 0. Neglect gravity effect, so means body force we are not considering. Here also v is equal to 0, w is equal to 0, so rho e by rho x equal to 0. It is fully developed. So you are considering only fully developed conditions. Now what will happen? So straight away we can say here the difference is that main difference is that this part is 0. This part is 0. So we will get what everything else is because dou it's steady because of the that dou u by dou t will be 0. Dou u by dou x is 0 because fully developed. V is equal to 0, w is equal to 0. Another assumption. Dou p by dou x is not there. That is also 0. Dou u by dou x, so dou square u by dou x square will become 0. Then dou square u by dou z square also 0. No pressure this body force, so that time also 0. So we will get 0 is equal to mu into dou square u by dou y square. So if you simplify, then we will get dou square u by dou y square is equal to 0. Since u is depending only on y, we can write d square u by dy square is equal to 0. So ODE becomes, sorry, PDE becomes ODE now. Now we will go. Now what is the, if you integrate, you will get what? If you integrate, you will get du by dy is equal to z1. Then u is equal to, again if you are integrating, then u is equal to c1 y plus c2. Then we will apply the boundary condition at y is equal to 0, at y is equal to 0 and y is equal to h. So y is equal to 0, what is the velocity? At y is equal to 0, u is equal to 0 because it is fixed. And at y is equal to h, u is equal to v. Then by applying both boundary conditions, you will get u is equal to capital V pi by h. Okay. So this is the final expression of velocity profile, and from that we will. So it is, see, u is proportional to y. That means profile will be, profile is linear. Profile is linear, straight line, same slope everywhere, same slope everywhere. So this is difference. So major difference between first is pressure driven. Poisson flow is pressure driven. Velocity profile is parabolic. That is 90. Second one is velocity driven. Velocity driven and profile velocity profile will be linear. That is two different things. Okay, So that is what is called. Uh, Now this is the final expression for uh, Couty flow. So this is the Couty flow. Okay. Now we will go back and we will do some